In this section, we're talking about hypothesis testing for standard deviations. So you're going to have to use the chi-squared test statistic. And if you look at your chart here, we're doing standard deviation. If you look over at the last row or last column, there's no stat crunch steps. So we are going to have to use the formula here, where any of the other times you had a choice, or depending what they gave you, you could use the formula or the stat crunch steps. Here we are going to have to use the formula. But first, let's look at our claim. This says a simple random sample of 47 men from a normally distributed population results in a standard deviation of 8.4 beats per minute. The normal range of pulse rates of adults is typically given as 60 to 100 beats per minute. If the range rule of thumb is applied to that normal range, the result is a standard deviation of 10 beats per minute. Use the sample result with a 0.05 significance level to test the claim that the pulse rates of men have a standard deviation equal to 10 beats per minute. Complete parts A through D. So here my claim is test the claim that the pulse rates are equal to 10. So that means that would be my null hypothesis, and not equal would be my alternative hypothesis. And then it wants me to find the test statistic. So I've gotten my HO is my standard deviation is equal to 10, and my H1 is that it's not equal to 10. This was my original claim. I also know, because this is not equal, that I'm two-tailed. So when I draw my picture, I've got two tails, and my alpha is 0.05, so I'm dividing that between the two tails. Now I'm down to step 5 now, which is find the test statistic, and we're doing standard deviation. So I'm going to have a chi-squared test statistic, which uses the formula n minus 1 times s squared over the population standard deviation squared. So I know n is 47. I know my sample standard deviation is 8.4, and my population standard deviation comes from my claim is 10. So I'm going to have n minus 1 will be 46, and then I'm going to have 8.4 squared, and then I'm going to have 10 squared. So on your calculator, because this is just multiplication and division, you can just enter it just like that. 46 times 8.4 squared divided by 10 squared is going to give me 32.46. So my chi-squared test statistic is 32.46. Ooh, it wanted more decimal places. It wants 3, so 458. Let's change that. And that is your test statistic. Now to find the p-value, you've got to be careful where our beats per minute are ranging from 60 to 100. So you kind of have to use your common sense to tell you whether this is the chi-squared to the right or the chi-squared to the left. Since we're going from 60 to 100, I'm going to assume it's the left side. So when I go to find my p-value here, I'm going to treat it like it's left side, and then I'm going to double it. So when you go to StatCrunch, and you're going to do stat calculators chi-squared, my degrees of freedom are n-1, so 46, and then less than, I put my test statistic there and press compute. That gives me my area on the left, but I'm two-tailed, so I need to double that. So I'm going to do 0.0656 times 2 will give me my p-value. So my p-value is 0.1312. And the reason I doubled it is because I'm two-tailed. And then from there, you're going to compare that p-value to the alpha, which was 0.05, and go through steps 7 and 8 to see what your conclusion is. In this case, my p-value is greater than the alpha, so I'm going to fail to reject the null, and my original claim was in the null, so I'm doing the second statement. My claim is in the null, and I failed to reject it, so there's not sufficient evidence to warrant rejection.